Hello, anatomy colleagues. My name is Dr. Kathleen Alsop, and I am super excited to get to start your first block in Anatomy 403. And I'm excited about it for numerous reasons. I kind of like to go first, but I also get to talk about one of my all-time favorite regions of anatomy, which is the musculoskeletal system. And not only do I get to talk about the musculoskeletal system, I get to start the conversation with my favorite part of MSK, which is the skeletal system. So I will have these videos split into kind of mini lectures, and we'll get through all the fun stuff and the interesting concepts that we have in the musculoskeletal system. So let's get right into it. So for each mini lecture, I'm going to have a list of questions, and these are your learning objectives. And I highly recommend that after you have viewed or kind of throughout viewing these mini lectures, that you try to answer these questions on your own. So what I mean by that is use your own words and your own flow charts or your own tables or whatever works for you to answer these questions. I also want to note that these questions generally can't be answered in 1 or 2 words. Generally, you're going to have to write a sentence or 2, or maybe have a chart or something that goes along with each one of these answers. If you can answer all of these, you're going to do great on the test. This is exactly where these the assessment questions come from. So really make sure that you're able to answer these questions after each one of these mini lectures. If you can't, that means that it's a great time to reach out to either your colleagues on Piazza. You can talk to me regarding these questions, but do make sure that you are engaging with these learning objectives and you get the answers through the videos, okay? So something that I'll bring up a few other times, but really we want you to focus in on these. All right, let's get into it. Yay. I love this image right here. This is going to be something that's going to come up kind of through these more foundational concepts. And so let's do a real quick test right off the bat. When you think of the skeletal system, what do you think of? What's the first thing that comes to your mind? I bet about 99.9% of you think bone, and that's great because that makes sense. The skeletal system is made up of bone, and that's hugely important, but there are other components that are going to allow for the bone to function properly. They're going to allow for the bones to be connected to one another at joints. So there are other components of bone that we want to talk about. And one other concept I want to make sure that we understand before we move into that nitty-gritty there is that bone is a dynamic organ. So dynamic, I have it bolded and italicized, so you know you probably want to focus in on that. So what does that even mean? What does it mean for it to be a dynamic organ? Well, it means that it changes. It changes throughout life. It doesn't just grow to its adult size and stop changing. And that's like an important component. Obviously, some of the major changes do happen embryologically or during childhood while the bone is growing in terms of length and kind of reaching that adult size. But even after that has halted, after bone length growth has halted, there is still change throughout life. And this is often referred to as bone remodeling. And so you can have increases in terms of bone density. You can have decreases in terms of bone density. And that's something that often happens with aging. And we'll talk about kind of how that happens or why. But the fact that the bone remodels throughout life is hugely important in terms of the musculoskeletal system. In fact, about 10% of bone changes every year in a healthy, active adult. So bone remodeling is normal. There can be some things that make it pathological, and we'll talk about some of those components, but typical bone remodeling is a good thing, and it plays a role in terms of bone being a dynamic organ. All right, so let's move on to the meat of our discussion, which is actually the skeletal system components and what it's made up of. And as you might imagine, the majority of the skeletal system is made up of bony or osseous tissue. So anytime you see osseous or os, think bone. And so obviously this is hugely important. It's the major component of bone, and we will spend time reviewing some of the specifics of that composition of the osseous tissue in an upcoming video. But before we move on from that, there are a few foundational things about osseous tissue that I want us to touch on here. And the first is that osseous tissue is a mineralized connective tissue. And remember, we talked a little bit about connective tissue in the previous session. Connective tissue is going to have that large amount of extracellular matrix with kind of widely dispersed cells, or kind of how that's spread out is different depending on what type of connective tissue. So osseous tissue is one of those 5 major mature connective tissues. And what's unique about osseous tissue in terms of that extracellular matrix is that it is going to be calcified or ossified. Sometimes you'll hear it referred to as ossified, and we'll talk about how that's not exactly correct there. But the point is that it's going to be hard. Okay, so that extracellular matrix is going to be hard, and that's what makes it kind of unique compared to other connective tissues. Spending a little bit more time on this extracellular matrix, it's going to be composed of 2 major components, and both are equally important in terms of the maintenance and the function of bone. And the first one I want to talk about is the organic component of the extracellular matrix, and you can see that over here on this chart. The organic component is mostly going to be composed of collagen fibers. And collagen fibers that's going to be composed mostly of the protein collagen. It's very, very strong, but very, very important in terms of resisting stretching. So it has a high tensile strength associated with it. We'll come back to this term in the next slide. But collagen is not stiff. That's an important component. So it's going to confer some flexibility to the bone. And you don't typically think, oh, I want my bones to be flexible. Well, you don't want them too flexible, but you do need some flexibility in order to be able to withstand a lot of the forces that are conferred upon bone. So organic is very important. There are other, and so collagen is kind of the big one here. There are other components of the organic portions of the extracellular matrix, but don't worry so much about those specifics. Collagen is kind of, if you've got that down, we're feeling good there. The inorganic component of the extracellular matrix is composed of mineral salts. Hydroxyapatite is going to be kind of the big one. We'll talk about that in more detail. You're going to have these minerals, they're going to harden or they're going to calcify, and that is going to confer the hardness that's associated with bone. So really important in terms of support and protection of more internal organs as well. All right, so we'll discuss some of the specifics of how bone will actually end up looking like this in terms of histologically, but I did want to introduce some of those concepts here. And before we move on to the other components of the skeletal system, I do want to take a terminology break because as you will find out, and as we know, anatomy is almost like a completely different language that you're learning. And so sometimes I want to take some time to kind of slow down and think through some of the terms that are going to come up either throughout musculoskeletal block or throughout the entirety of the course. And one of those areas I really want to make sure that we feel comfortable with are the different types of strengths that can play a role in terms of the musculoskeletal system, or the different types of forces that can occur. And so you're going to have specific components of the skeletal system that are there to kind of withstand these forces. And this is not only in terms of bone, this is going to play a role in terms of cartilage and tendons and ligaments. So these terms are going to come up quite a bit throughout the musculoskeletal portion, and particularly this term here, tensile strength. And what this means is this is the maximum strength that a structure can withstand while being stretched or pulled before you have some type of failure or some type of damage. So tensile strength is hugely important in terms of the musculoskeletal system. It's generally due to those collagen fibers that we talked about in terms of the organic material of the extracellular matrix. But it's not only in osseous tissue, you'll also have them associated. You'll have collagen associated with cartilage, as well as some of the tendons and ligaments. So tensile strength, put a big star next to it. This is something I definitely want you to make sure that you walk away with. There are other types of forces that can play a role. Compression strength or force is going to be that maximum strength that a structure can withstand while being compressed, as the name would suggest, or crushed or squeezed. So you can kind of see those arrows, or that force is kind of coming and causing things to be compressed. And so this can play a role, as well as shearing or shear strength. That's going to be the strength that a structure can withstand while certain portions are being pulled in different directions. And so how much can that structure withstand before you reach failure? So all three of these are going to come up. Again, tensile strength is going to come up a lot. So do make sure that you feel comfortable with that before moving on. All right, moving on to the other components of the skeletal system. And while cartilage doesn't have, it's not part of the abbreviation of MSK or the musculoskeletal system, cartilage almost should be, because it's playing a huge role in terms of the musculoskeletal system as a whole, but also in terms of specifically the skeletal system as well. And like osseous tissue, cartilage is one of the major mature connective tissues as well. And cartilage is going to play a role in terms of the skeletal system in two ways. And the first is going to be bone ossification. You can see an example of how that works down here. Don't worry so much about these steps quite yet. We will talk about them in an upcoming session. And when we're talking about ossification, I want you to think bone formation. So how does it actually form? And for most of the bones of the body, they actually form within a cartilage model first. Okay, so that cartilage model develops, it grows, and then it's eventually replaced by bony tissue. So very important, most of the long bones of the body, all the long bones of the body are going to be formed through endochondral ossification. The other major way that cartilage plays a role in the skeletal system is through joints. And either the cartilage is the actual connective tissue that is joining or articulating the bones, and that's in the cases of cartilaginous joints, and we'll talk about those specifics in an upcoming session, or cartilage will cover the ends of long bones. So it's not what's actually connecting a bone to another bone, but you will have a layer of cartilage on the end of the bone to serve as kind of an area for shock absorption and protection to those areas. And so you'll have this articular cartilage, and the type of joints referred to as synovial joints. And we'll spend a tremendous amount of time on synovial joints because most joints of the body are synovial. So those more freely movable joints of the body. So think shoulder, elbow, hip, knee, those are all examples of synovial joints, and the bones associated with those joints on the ends will have this layer of articular cartilage. Most cartilage of the body, but also in terms of the musculoskeletal system, is going to be hyaline cartilage. So we'll come back to hyaline cartilage in a bit more detail. And another thing I want to note about cartilage before we move on is that it is what's referred to as mostly avascular. A as in the letter A, avascular. And this is an important concept because most of the skeletal system actually has a very rich vascular supply. Cartilage does not. And that means that either there's no blood supply or a poor blood supply. And that has big implications in terms of healing. If you have damage to cartilage, it actually doesn't heal quite as well as, say, bony tissue, because you don't have those nutrients, you don't have that oxygen reaching that tissue to the same level as you do in structures that have a very rich vascular supply. So we'll come back to this as has implications in terms of, say, osteoarthritis, because that can have damage to the articular cartilage and it can't heal. So, or it doesn't heal as fast. So that has some big issues that come up. All right, another type of connective tissue, dense connective tissue. So we're getting almost all those 5 types of connective tissues right here in the skeletal system. Dense connective tissue is going to play a role in terms of the skeletal system. And dense connective tissue, as its name would suggest, with this dense here, is going to appear denser microscopically due to a higher frequency of fibers, which are denser and more tightly packed. So that it will appear denser microscopically. There's 3 major areas of dense connective tissue that I'm going to touch base on. The first is the periosteum. You can see that here in this image. You can see it really well here. So this is the actual bony tissue, and you can see the periosteum is kind of on the outside of the bone. You can see it's peeled off to kind of show what it looks like there. The periosteum is going to be surrounding the entirety of the bone, except for where there's articular cartilage. It's actually going to be tethered to the bone by specific fibers that kind of interweave and go through that osseous tissue. So very, very closely connected there. We'll talk about it in a bit more detail when we talk about the parts of the long bone, because you're going to have cells that kind of hang out in this region and allow for bony growth or changes to occur and remodeling. It also plays a protective role of the bone. So if you ever look at a bone and it looks kind of shiny on the outside, it's this periosteum that's giving it kind of that shiny appearance. And this is actually going to be made up of generally dense irregular connective tissue. These other 2, ligaments and tendons, typically have an attachment to bone as well. So they're going to send some fibers into the actual matrix of the bone. So you have these really close connections. And so very, very closely related to the skeletal system. Both are typically composed of dense, regular connective tissue. So those collagen fibers are going to be more regularly arranged in bundles. Ligaments, and we can look over here, this is the side of a knee joint right here. Ligaments are going to connect bone to bone. All right. So bone to bone. So you're looking at the anterior cruciate ligament, or your ACL. That's going to go from the femur to the tibia. So attaching bone to bone, very important in terms of joints. Tendons are going to attach muscle to bone. So you can see right here your quadriceps femoris muscle, so your quads and the anterior thigh. Here is a tendon right here. They are going to appear opaque and white, and that's going to attach to bone, in this case, the patella right here, and it'll actually extend all the way to the tibia as well. So ligaments are bone to bone, tendons are muscle to bone. This is your first kind of intro here. We will talk about it in great detail as we talk about regional musculoskeletal anatomy. All right, bone marrow is another component of bone. So bone marrow is going to be housed within bony tissue. All right, so this is an important concept. It will appear kind of soft and pulpy, and it will be found in hollow spaces of the bone. All right. And there are 2 major types. There is going to, and the amount of these 2 different types will differ depending on age. So how much bone marrow type, how much red bone marrow you have is significantly different in a young child than an adult. It depends on the bone type. It depends on the location, even within the same bone, and other factors. And you can really, if you're looking down at this image, they really do appear like the color that they say. So you have this yellow bone marrow here, kind of more towards the middle. And then you have the red, so that's yellow bone marrow. And then you have the red kind of throughout here. And the red looks red because of blood. And we'll talk about that in a moment. So red bone marrow is found throughout the skeleton in the fetus, as well as during the first year of life. And what's important about red bone marrow is that it is hemopoietic, hemopoiesis. It'll play a role in terms of that. That's always been a hard word for me to say. And what that means is that it is blood forming. All right, so this is a structure where blood is actually being formed, specifically the formed elements of blood. You'll have a whole lecture on blood in an upcoming block. So I don't want to get into the specifics of how blood is formed, but since it is going to form within red bone marrow, which is housed within bone, I do want to mention that here. In childhood, much of that red bone marrow is going to be gradually replaced by what's referred to as yellow bone marrow. However, red bone marrow does persist in certain bones, such as the vertebrae, so associated with the spinal column, the sternum or your breastbone, ribs will still have red bone marrow, the clavicles or your collarbones, your scapula or your shoulder blade, your hip bones, and then some of the proximal ends or the epiphyses of some of your longer long bones, so the humerus as well as the femur. Now, yellow bone marrow is a network of connective tissue that is going to support numerous types of cells, but the most numerous of those cells are going to be adipocytes. And adipocytes are going to be fat forming. And so really, this is kind of a collection of fatty tissue that generally is going to be found in the hollow portions of the shafts or the bodies of long bones. So if you were to kind of cut through a bone, a long bone, generally that middle portion is going to be filled up with this yellow bone marrow. If you remove that yellow bone marrow, it would look completely hollow in that region. And finally, it's important to note that the skeletal system has a very rich neurovascular supply. And neurovasculature is another concept that will be prominent throughout the course. You're going to have an entire block on neuroanatomy. You're going to have portions of a block that's going to be focused in on arteries and veins. And the reason is that these structures are vital to the function of the body. They're hugely important. So we're going to spend a lot of time there. But I do want to introduce these concepts here because they're important in terms of the function of the musculoskeletal system. Even though they're not the star of the show, they are going to play a role in terms of the bones being able to remodel throughout life. They're going to play a huge role in terms of muscles being able to contract and to move those bones. So I'm going to introduce these terms here, and then you will talk about them in much greater detail in upcoming sessions. One thing I do want to note in terms of anatomy illustrations is that arteries are always going to show up as red. So arteries are red in anatomy illustrations, veins are blue, and nerves are yellow. So if you're looking at here at a typical neurovascular bundle, the yellow there is nerve, the blue is veins, the red are arteries. Oftentimes you'll also see green structures, and these are lymphatic vessels or lymph, and you'll talk a lot more about lymph in an upcoming session. So almost the entirety of the skeletal system has an extremely robust blood supply or arterial supply, except for cartilage. But if you're looking here over at this bone, you see blue and red all over the place, so you have arteries and veins all over the place. So real basic, let's start with what an artery is, what a vein is, and what a nerve is. And again, you'll get into much more detail in upcoming sessions. So arteries are blood vessels that are going to carry blood away from the heart, and it's going to other tissues, all right? So it's carrying blood to other tissues away from the heart. The away part is really kind of that definitional portion of the arteries. Now, most arteries, not all, and you'll talk about that in the cardiorespiratory sequence, but most arteries, particularly when we're talking about the musculoskeletal system, are going to carry oxygenated blood to tissues. So carrying oxygen and nutrients to those tissues in order to allow them to function properly. So those are arteries. Veins are going to be the blood vessels that can convey blood back to the heart. So they're carrying blood away from those tissues back to the heart. So back to is kind of the key here. And most, but not all, again, but most veins are going to be carrying deoxygenated blood away from the tissues back to the heart. So this is where you get the majority of the oxygen and nutrients with the arteries, and this is carrying that deoxygenated blood away from the tissues. There are some specific examples of where that the oxygenated and deoxygenated are not the case, and you'll talk about those in upcoming sessions. But for our part, let's think arteries are bringing the oxygen, veins are taking the deoxygenated blood away. And then last, and the neuro part of neurovasculature are going to be the nerves. And nerves are going to be bundles of axons that are kind of wrapped up together in connective tissue that are located outside the central nervous system. So CNS stands for central nervous system. And it's really, these nerves are how you have this communication between other tissues in the body and that central nervous system in order for the processing to occur and to allow for communication there. So much, much more to come in terms of neurovasculature, but did want to make sure you understood that there is a very important and prominent blood supply to the musculoskeletal system, except for in the case of cartilage. So kind of coming full circle back into bone being a dynamic organ, because we have these structures to allow for bone remodeling to occur. All right. Now I like to end all of my mini lectures with a question to allow yourself to kind of test your comfort and your comprehension of some of the more important concepts here. Many of them are going to be similar to what you would see on exam, not all of them. This is actually a good case of a kind of typical exam question, or typical kind of how my exam questions are going to be written. So this will be important in terms of comprehending. I very much recommend that you try to answer this on your own. Pause the video, think through it, and then you can unpause the video, and I will always kind of go through the question as well in terms of why the correct answer is correct and the incorrect answers are incorrect. So which component of the skeletal system is important in terms of hemopoiesis or blood forming? So pause it. And then when you're ready, let's talk about, and hopefully we're all kind of homing in on D being the correct answer, or red bone marrow. Red bone marrow is going to be kind of that principal site for blood formation, specifically those formed elements of blood. And I did put A in here to be a little tricky. I don't like to be tricky generally, but I did want to put this in here as a good distractor, because while arteries are definitely important in terms of transporting blood, so allowing blood to move through the arteries to get to the specific tissues that they need to get to, it's not the arteries that the blood, that's not where the blood is actually forming. All right. It's important in terms of transport, but it's not going to be important in terms of blood formation. Hyaline cartilage is definitely wrong. We know that cartilage is mostly avascular, so we're off in the wrong section there. Osseous tissue is a little tricky too, because you're going to have the red bone marrow being housed within the hollow portions of bone, but it's not actually forming within the osseous tissue specifically. It's going to be forming in this specific type of marrow, and it's not the yellow bone marrow either. Yellow bone marrow is not, it can be replaced by red bone marrow in kind of specific cases if need arises, but yellow bone marrow itself will not be blood forming. So yellow bone marrow is wrong. Red bone marrow is where we want to be at in terms of this question. If you got it right, excellent. You have probably this down. You probably don't need to spend too much more time of your studying thinking about this. If you didn't get it right, take it as an opportunity to understand that perhaps I don't get this concept as well, and I need to spend a little bit more time understanding this. And that's where you can reach out to your colleagues on Piazza. You can reach out to me if you would like, and we can kind of work through that concept. All right, excellent. Well, thank you so much for your time and attention here. Take time, if you haven't already, to answer those learning objectives, and let's move on to the next section. Thanks.